Oh, okay, ladies and gentlemen, this is question number 5, this family in Germany question. So I've already drawn the diagram just to speed this up just a slight little bit. Um, so what we're asked is that family in Germany drives at 140 kilometers per hour for 45 minutes on a bearing of that. That's this line here. And then 180 for 40 minutes on the bearing of that. That's roughly that angle there. Find the distance and the bearing of the car from its starting point. Okay, so let me just get some of these details in. So 140 times 0.75 gives me 105 for that one, and it was 180 times 2/3 of an hour is 120. Okay. So just getting these details into this particular thing, we know that this is 32. We know that this is 105. We know that this bearing is 317, which would give me, there's 43 degrees here. And we know that this is 120 kilometers. The things that we're asked to find are that, and then I think this is where this question went off the rails for some of you. It says the distance bearing of the car from its starting point. So the bearing that we are looking for is this bearing right here. That one that I just drew in blue is the one because it's from the starting point. So that I think is the catch. But anyway, let's go ahead and do the distance. So x squared is going to be a squared plus b squared minus 2ab cosine c. Obviously that is cosine rule. So x is going to be the square root of 105 squared plus 120 squared minus 2 times 120 times 105 times the cosine of, we need to know what that cosine is. So we got to find that. All right, so we know because of alternate interior angles that we've got 32 degrees right there. If we have 43 here, then what's left is 180 minus, I'm going to call this theta for now. Theta is 180 minus 32 plus 43. That's 75, so it's 105 degrees. So if I just plop in that 105 degrees here, so it's cosine 105. All right, so that'll give us our value of x. I don't think many people had trouble with that. I just want to make sure that we're showing it. So it was 105 squared plus 120 squared minus 2 times 105 times 120 times the cosine of 105 degrees. I want a decimal, so I got to put a decimal in. I get 178.738. So we know that x is approximately 178.738, which would give me about 179 kilometers. So that is done. So now, in order to find this, the bearing, what I need to do is get more colors. I need to find what this angle in the triangle is. I'm going to call that phi for now. And what's going to happen is that what I need phi minus the 32 degrees, because realistically, we're looking for that little itty bitty angle. So I'm going to take that and all of this, I'm going to subtract from 360, and that will give me that bearing. That'll give me that bearing going around here, this bearing that we've drawn in the blue, okay? So in order to do that, we're going to have to use sine rule, right? The sine of 105 over that 179. Again, when I put in my calculator, I'm going to use the exact value that I got from my calculator, the full calculator display. And that's going to be equal to 120 over the sine of my unknown angle phi, okay? So from there, I would end up with phi has got to be the arc sine of 120 times the sine of 105 all over that 179. Okay, so let's go ahead and plug and play that with our calculator. So the arc sine of 120 times the sine of, we said it was 105, all of that divided by that answer. So that gives me 40.4284. So now I know what that phi value is. 40.42 blah, blah, blah. Okay, so now I'm just going to take advantage of this and do that 360 minus the 40.42 minus 32, and that will give me my bearing. So 360 minus the quantity that minus 32 degrees, and I get a bearing of 351.572. So my true bearing going from the car to, or from the starting point to the car, my true bearing is going to be 351.7 something, which is approximately 352 degrees. Hope that's helpful.